Hey, welcome back. So in our example file here, we have a pie chart, which is commonly used for showing how different values make up parts of a whole. Now, pie charts are okay if we only want to see a breakout of a single field with a small handful of unique values. But for anything more complicated than that, things start to break down. Just for example, let's see what happens if we try to add product name to our pie chart in addition to the product category field we're already breaking out. So I'll select my chart, and then on my field list, I'll just drag in product name under product category. Whoa, that is a lot of little slices of slightly different colors. And if I drag out this corner of the chart to expand it, we see that our legend gets ever longer, and the bigger I make the chart, the more items the legend is able to show. But this is almost making things worse. What normal user could possibly make any sense of this mess? So as you can see, if we want to show proportions of profit or any other measure by product categories and then products within each product category, pie charts just won't cut it. They simply aren't equipped to handle a lot of values, much less to show hierarchical relationships like the relationship between product category and product. But one chart which can do those things effectively is called a tree map. So let's try to convert our sad little pie chart here to a tree map. So first let's contract this chart back to somewhat normal dimensions. And then I'll go up to my Design tab and choose Change Chart Type. And then down here we see Tree Map. So I'll click that. And oh no, Excel is telling us you can't create this chart type with data inside a pivot table. Please select a different chart type or copy the data outside the pivot table. So this disappointing little message is an example of the limitations of pivot charts. While you should always use pivot charts if you can, sometimes you just need something you can only get with standard Excel charts. But fortunately, there's a way to create a standard Excel chart that's still plugged in to the Excel data model. Let's see how. Now the first step is to create a pivot table with the data that will form the basis of our chart. So first I'll cancel out of this, and I'll go ahead and delete our little pie chart here, and then I'll create a pivot table with product category and product name on rows, and then our new dynamic measure on values. Now don't panic, our pivot table is returning no rows because the measure we've selected requires us to select a single value using a slicer. So right now we haven't done that yet, so our measure is returning blanks for every possible set of coordinates in our pivot table, so our pivot table doesn't have any rows. So our next step obviously is to insert a slicer. So we'll click Insert Slicer, and then we'll go down to our slicer table and add our measures field. And then just to get our pivot table to fill out a bit, we'll select one of our measures. And there we are. Now we're getting data for that particular measure in our pivot table. So I'll convert my slicer to be 3 columns wide and then resize it just a bit to make it fit our overall design just a bit better. And now we'll turn our attention back to our pivot table. So note the way our pivot table is laid out, with values from multiple different fields, that being product category and product, in the same column, column B. In addition, these values aren't repeated for every row. Instead, we only see each unique row label once. Now, while this layout may be great for making our pivot tables condensed and readable, it's not going to work as the source for a standard Excel chart. Standard Excel charts expect the data we feed them to be neatly organized in rows and columns, with no gaps in the data. So the first step then is to change the layout of our pivot table accordingly. And this is actually something we saw how to do just a few videos back. So we'll go to our Design tab, and then Report Layout, and then Show in Tabular Form. And then back under Report Layout, we'll choose Repeat All Item Labels. So now we have a column for each field in our pivot table, and we don't have any gaps in those item labels. every row of every column in our pivot table has a value. So at this point, we, in theory, are ready to create our tree map chart. So let's highlight all the data in our pivot, and then go to Insert, and then in the Charts section of the Insert tab, I'll click this button that has a tooltip that says Insert Hierarchy Chart. So that gives me the option to choose either a tree map or a sunburst. We'll choose the tree map. And now, once again, we get slapped on the wrist by Excel. Excel says you can't create this type of chart with data inside a pivot table. So not only will Excel not allow us to create a tree map as a pivot chart, it also won't let us create a tree map just directly from the data inside a pivot table. Okay, so now we know we can't reference the pivot table directly in any way, shape, or form. Now we could just copy and paste this data out of the pivot table, but then we just have a static chart that's no longer connected to the data model and can't be manipulated or filtered by a slicer. Now obviously that's not what we want, so what's the solution? The answer is to convert our pivot table to formulas. Now that may sound kind of crazy, so the best thing to do is probably just to go ahead and do it and then show you what it looks like and how it works afterwards. So first I'll click out of this error message, and then to convert our pivot table to formulas, while we still have it selected, we'll go to our Pivot Table Analyze tab, and then in this Calculations section, we'll click the arrow next to OLAP Tools, and then choose Convert to Formulas. Now before we hit this proverbial big red button, I want to caution you that any slicers that you want to be able to manipulate your pivot table formulas with already need to be connected to your pivot table before you take this step. Once you convert your pivot table to formulas, adding a slicer that manipulates those formulas will not be easy. It's possible, but it requires a lot of knowledge about how to manipulate the formulas that we're about to see. So again, I would recommend, if you want to be able to manipulate those formulas with a slicer, make sure that slicer is connected to the pivot before we convert the pivot to formulas. Now we've already got our slicer in place, so we should be good to go. So I'll just click this Convert to Formulas button. And now we see that all of our data is still in place and unchanged, but our formatting is gone. And if I click in any of these cells, we see that instead of just a value, we have a formula called cube member with lots of scary looking arguments inside. Now keep in mind, this is just an Excel formula, and if you were incredibly knowledgeable about the cube member function, you could feasibly write this from scratch. But does this really look like something you'd want to write from scratch? Probably not. So the smart play is to get your pivot table layout exactly like you want, then connect any slicers to your pivot table that you want to be able to manipulate your formulas with, and only then convert your pivot table to formulas. So now let's see what happens to these values when I start selecting different measures in my slicer. And as you can see, the values in our dynamic measure column change every time I choose a different measure in my slicer. So these formulas are obviously responsive to a slicer in the same way that a pivot table is. And further, they're still connected to the data model. So if the underlying data in our data model changes, these values in our formulas will change as well. So in that sense, you get most of the benefits of a pivot table, but the flexibility of a formula. Now, what's an example of that flexibility, you might ask? Well, one example is you can actually move the cells containing these formulas around with absolutely no consequences. So if for whatever reason I just wanted to move these first 3 rows of my pivot table somewhere else, I can with no problem at all. So if, for example, you were creating a dynamic dashboard and you just wanted the grand total cell from this particular pivot table using all the logic in the pivot table and connected to that slicer that we set up, you could just move this one cell on the first page of your dynamic dashboard and control that single total with your slicer. And if you wanted, you could just delete the rest of these formulas. So again, these formulas are connected to the data model and they can be controlled dynamically with a slicer, but you can also move them around and delete them in the same way that you would any other cell that has an Excel formula. And to further demonstrate this flexibility, I actually don't even need this grand total for the purpose of our tree map because we don't want to include that in the chart. We're just trying to chart the individual products and their categories, not the overall number. So I can delete that, and I'll also delete the rest of this grand total row. And then I'll move these first 3 rows back into their original spot. And at this point, I think we're ready to create our tree map. So again, I'll highlight this range of cells, and then go to Insert, Hierarchy Chart, and Tree Map. And look at that. While this chart could certainly benefit from being expanded just a bit because we have 25 products, which is going to make for a crowded chart no matter what layout we choose, we can now see a clear hierarchy from product category down to individual product, and then among all of the different products. We can clearly see that for the particular measure we've chosen, which appears to be line items sold, that our beach supplies product category has the biggest proportion, our surfing products category has the second biggest, and our riding supplies category has the smallest. And then within our beach supplies category, we see that straw hat appears to be the biggest seller, and then sunblock, and so on and so forth. So as you can see, tree maps are really great at not just showing proportions among different categories of our data like pie charts, they're also great at showing these hierarchical relationships. And they're much better at handling a larger number of categories that we're trying to compare. And just to prove to you that our chart is still connected to our slicer, let's change our measure. And as you can see, our whole chart changes around. Now, while beach supplies made up a bigger proportion of our line items sold measure, our surfing products make up a much bigger portion of our profits, which kind of makes sense because our surfing products are more expensive. Now, one caveat here is that charts update dynamically based on their underlying data. So if we were to delete this range of formulas that we just created, our chart would go blank. So we can't delete our formulas. However, if we're not interested in seeing this underlying data on our reporter dashboard, we can simply move our chart to a different tab. So I can select the chart and then hit Ctrl-X to cut it, then create a new worksheet and just paste our chart in there. And then I can do the same thing with our slicer. And now we've taken one step closer to being able to create a true dynamic dashboard and with any selection of charts that we choose. Now to that point, we can actually create another chart here, which is just a standard pivot chart, and connect it to the same slicer. So now we're using that slicer to control a conventional chart that's plugged into our data model via formulas, which is the one we see here, and then a pivot chart, which is directly connected to the data model. So let's create a pivot chart directly from our data model, and we'll put year and quarter on rows, and then we'll put our dynamic measure on values. Now right now our chart is showing it blank because we haven't connected it to our slicer. But all we have to do is select our slicer, right click, and choose Report Connections. And now we see our brand new pivot chart available to us to select as an option. So we'll check that and click OK. And now our pivot chart is connected to our slicer. And then if I choose a different metric, our pivot chart changes as we would expect. And just to spruce up our pivot chart a bit, I think I'll add product category. So I'll go under our products table, and then I'll drag in product category under our legend. And then since we're showing a time series, I think I'll convert the chart type to line. And then I'll get rid of all of these filter buttons that are cluttering up our chart. And then we'll just reposition here a little bit to get these charts and our slicer aligned in a logical way. And maybe I'll even delete the title of our tree map, since our tree map combined with our slicer makes what we're presenting pretty self-explanatory. And now as I select different measures in our slicer, both of our charts respond to our selection. And obviously, as you can imagine, you're not limited to just 2 charts. You can use this method to have a single slicer control as many charts as you want, and as we've seen, we're not just limited to the charts that are available to you as pivot charts. If you're willing to get just a little bit creative and convert your pivot tables to formulas, you can use this method to control any kind of chart. And to that point, this is just one example of a chart type that is not available to you as a pivot chart. There are several other examples of charts that cannot be created based on data in a pivot table that can be created in this way. In general, the steps to do this are: first, understand how the data has to be structured to create the chart from scratch. Then, mirror a pivot table to this structure as closely as possible. Then make sure to add any slicers you'd like to use to filter your formulas. Then convert the pivot table to formulas as we saw. And then finally, reposition and/or delete formulas as needed and build out your chart. Now there's one major caveat here, however. If the values in the fields you're using for your rows or column labels change a lot, and especially if new values are constantly being added to them, this may not be the best approach. That's because these formulas are based on the exact structure of the pivot table as it was when you converted it to formulas. If new labels are added, for example, if we add new product names or product categories, new formulas will not automatically be created in turn. Okay, so I hope in this section you've enjoyed learning how to use Microsoft Excel's business intelligence tools to build dynamic and visually appealing reporting and business intelligence solutions. Now, as much as you've learned so far, we've really only scratched the surface, but I think you know enough now to teach yourself any additional techniques you might need in any given situation to solve the problem you're trying to solve. So best of luck, and I look forward to seeing you in another course.